Okay, so let's start really. So my name is Franklin Okpako, and today I'll be talking about infrastructure security, malicious compliance, and using chip clarity for managing your CVs itself. So let's start. Um, how many of you here have used like a vulnerability scanner before? Oh, okay, nice, nice, nice. Okay, how about CVs? Like you've heard about CVs, right? Like vulnerability CVs, right? Okay. How many of us here have had to fix CVs or fix what they call remediate it or mitigate it? Anyone? Show of hands. Okay. It's a pain, right? Can be a pain. Okay. So this talk itself, okay, let me introduce myself. I'll go. Uh, so currently, I work as the engineering lead at Nautilus Technology, where we offer like DevOps consultancy services as well as blockchain related services as well. And I think majorly I also work as a DevOps engineer in the Web3 space. So yeah, that's it. So what this talk would be about is I'm gonna give you like a rundown or what you should expect itself, right? So at the end of the day, every now and then, like it's something called like the software security and supply chain, right? It's I'm gonna be talking like how life has evolved in terms of like how we have so much like um, um, surface attack. It has so much increased over the years as well. And basically, what CVEs are itself, right? And when we understand CVEs, do we always have to fix them, right? Is there a way that we can fix them? Is there a way that we can identify these CVs or these vulnerabilities in our code itself? But then again, we then have to have the conversation that um, these scanners that we rely on for detecting these CVs, right? Are they really to be trusted? Like these scanners, what are they looking for really, right? And if we rely on these scanners to identify these vulnerabilities itself, is there a way that we can bypass these scanners itself and bring us to a point where we can say we are maliciously compliant? And would also talk briefly as regards like what it is to be compliant, why you find the balance between compliance and security, right? So does it mean that you want to fight for compliance and lose security? What are your trade-offs, right? What are the tricks? What is your risk appetite itself? And lastly, we would have like a short demo, right? And after the demo itself, then we end with me introducing you guys to Keep Clarity and how you can basically use Keep Clarity. It's going to be more of like an informative session itself, making you guys aware of what security risks out there that are available out there itself, right? So yeah, so let's get started. So I don't know who here is familiar with this log4j and vulnerability issues. Yeah, exactly. So ignore the photo, but you get the idea. This is like young Yoda, and after the security vulnerability, this is Yoda itself. So you know how security is itself. You would always say you will patch it, you will do it or something, and before you know, when there's a vulnerability, then you end up find yourself in the deep ditch. Now, when you look everywhere itself, right, there's always something to scan itself, right? So yeah, this is just a quick memory itself. Okay, so CVs itself, like we know that there are always vulnerability. Your application has dependencies. Those dependencies itself are basically libraries made up of different libraries made up of different packages itself, right? Each of those packages itself, right? They every now and then, like there are people that are looking for ways to exploit to find a way that they can find backdoors into what is existing itself. So if that means that if we have like five alphabet itself and they're all dependencies, it's possible that dependency A can have like five other dependencies, and dependency, let's say D under A has another dependencies, just like so. It's a web of dependencies, and at the end of the day, like how do you then track it and manage your what they call your vulnerabilities within your applications and your infrastructure? So it can be a pain itself, and there's also called CVSS itself. It's a way that at the end of the day, you would always get vulnerabilities, right? You would always see it. So the question here is, how do you know which vulnerability you should attend to? Is it critical? Is it just high? Is it moderate itself? So, and it CVSS tells you like gives you like a score. I thought this was clearer. Sorry, but there's like a score itself. I think critical. This is like a 9.8. It's not clear, but this is like a 9.8 itself. And you can imagine you having a 9.8 CV, it's something that you want to fix. But the question then comes, not every CV you can fix. What about if it's an OS itself? You don't have control over it now. You basically run it itself. So what about the CVs that you cannot fix? How do you then go about it? How do you manage it itself? So it's just like one problem to the other itself. And I think recently this came SBOM itself, which is like a software bill of materials itself. At the end of the day, we talk more on SBOM, but think about SBOM like a list, like a structured data set, right? That has like so much information as regards to what is in your images, in your code itself, right? What is there without you don't, this is not the Docker file itself. I think the US government as of 2021, like Biden said that issued like a security order that for you to like even do any government contracts going forward, you have to practice like generating SBOM itself. So SBOM is a way that you can have visibility into what is in your code or what is in your application itself. So during our demo session, you understand why SBOM. And I think this is just we trying to practice vulnerability management, something that we have to identify what we want to prioritize, what we want to remediate, and what we want to mitigate, right? So that's it. So what are S bombs and what they are not or something itself, right? So like I said, S bomb has a lot of like information as regards your application itself, right? Like the software name, libraries, compliance, dependencies in those images itself. You want to get visibility into it itself. But at the end of the day, what it is more mainly like it's factual level of transparency into your software dependencies, into your libraries itself, licensing, and a couple of things. It is not a security solution itself, right? It's not going to fix your problem. It's not a vulnerability report itself. Think about it more like a process where we want to use that process to gain more visibility into what's in our applications. So the trick is knowing which one is to fix, which one is to mitigate, and which one to remediate. So this brings me to the software and security supply chain itself, right? When you think about it, there's a time that we could just code on our systems and just push it itself, right? Now, we have like, currently, we have like four layers. There are others, but let's just say these are like four major areas that are of really concern to everybody. So let's say, for instance, you have like on this one, you have like the infrastructure as code. It can be as regards of results of how will I put it now? Your misconfiguration when you're trying to do Terraform, when you're trying to do something, you do like a secret, you expose a secret, you commit to something. You understand? That is you increasing your attack surface as well. Then you come at containers itself. Like when you look at containers itself, it's basically mostly contains about libraries, OS packages and libraries itself. And in each of these itself, they all have dependencies, right? They all have libraries that have to be managed, right? And from there, vulnerabilities would always be discovered. So how do you then manage it? And come about open source. Open source is a pain, really. Like I say this all the time because when you run open source software sometimes and you're trying to practice your organization is one that tries to manage or has a good system for managing vulnerabilities and stuff. What happens when today you're running the system and the application works fine? The next time your pipeline runs, you're seeing like a critical vulnerability with 9.8. And you know something, right? The fact the scanner detected that vulnerability, it doesn't mean that it means that it's there already. Like your application is now prone to susceptible to security risk itself. It's already there already. So how do you then mitigate it? You do not build the application now. So you end up going to create an issue on their GitHub page and like, hey guys, like we discovered the CVEs. Can you fix it? How soon? If they are not serious, then come on, like then you have to find a way of how you want to go about it. Then your code itself is really as regards like your VS code, right? Like within itself, it can also be like a source of what's it called, vulnerability itself. So when you put all this, it's more like the new risk profile, or like what that's why they call it like this software supply and security chain itself, right? Because yeah, this basically categorizes like what we do in terms of like infrastructure as code and containers, open source, and your local codes itself. So at the end of the day, right, you do see all these CVEs. There's nothing that you can do, right? The CVs are there. How can you then manage these CVs? It's a pain. And your company has like a policy that you have to fix these CVs, these vulnerabilities, because it means that we can, if it's financial company, it means that money can lose, right? So how do you then go about it? So, but before we even think about fixing CVs and every other thing, we must first of all consider something. How do we detect these CVs? What are the scanners? Are they to be trusted? Why do we trust them? How do they work? Because when you understand how they work, then that means there's a way that you can be able to manage or better handle your security profile itself. So this brings us to a term I call, it's not, I came about it recently, um, malicious compliance. It's, I think it was done by a group of security hackers or something, I think GOMs on this recent CNCF itself. So malicious compliance, what does it mean to be malicious and yet compliant at the same time? So but before then, let's start with something like how well do you trust your containers, right? What are container scanners? What are the problems they're looking to solve, right? What are they scanning for? We need to know, right? It's not just I use 3V. Oh, okay, use 3V. Okay. How do you know 3V is actually scanning your images and detect and bringing the right all the vulnerabilities that are there itself? What are the shortcomings of those vulnerability scanners? And are you able to bypass those vulnerabilities? So this brings us to malicious compliance, like I said, and the trick is this: your all vulnerability scanners, there's a way they work, majorly in four ways. One is once you start the process, they're looking to identify what OS that image is using, right? Because you can't manage what you do not know. So the very first thing is they want to be able to detect what OS is that image is running at itself, right? And understand something, the image itself, the OS that the image uses can also have its own vulnerability. And so you then have OS detection as the first one. You have OS packages. OS packages are like your let's say iPine, for instance, right? Those packages, your young packages and something. Then you have dependency files. Dependency files like package to JSON, cargo, blah, 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 and every other thing, right? And you have binary metadata like chips, just your binaries, let's say, whatever. I can't recall any binaries, but let's see. So in this reflection that we're going to be partaking in the next couple of minutes, We basically will be using Trivy, Guide, Docker Scout, and Snake. Docker Scan was recently depreciated for Docker Scout, though Docker Scout under the hood uses Snake. Well, at the end of the day, I think it was part of the test that was done itself. It's an open source project itself, so I basically did not run all the tests itself. I compiled everything, and I'm just going to share it here for informational purposes itself. So now, OS detection itself, when your scanners run, irrespective of if you use 3V, irrespective of if you use GIPE or something, when your scanners run, right, remember the niche here is to understand how your scanners run, right? Because you must know how these things work for you to be able to mitigate whatever security vulnerability you find in your containers. So the very first thing like what vulnerability scanners look for is they try to detect what is the OS of that image itself, right? And there are certain files they look for. There are certain files they look for, right? It means that if those files are not there, do you think that they will be able to see those vulnerabilities? That's something I will figure out. So, files like Etsy, OS releases, and just like that. So once they detect it, then they know that, oh, okay, this is the OS this image is using, and they are able to better provide more visibility or information to the scanners themselves. The second one is package detection itself, right? So let's say they are not even able to detect the OS itself. They can be able to get information as regards what packages are in these systems or containers itself. So from there, they can be able to like scan it and also provide information as regards like what vulnerabilities that we are exposed to. And the third and fourth one are dependency files, right? So dependency files. So package.json, requirement.txt, and anyone basically. All vulnerability scanners look for these as well because so they look for these and basically scan what dependencies you have in them, and they try to then see if run it across the database and see if there are any vulnerabilities there. Then the last one there is like binary metadata itself, right? This is what is quite common, irrespective of whatever container vulnerability scanner you use. The last one is like binary metadata. So in most binaries itself, you have the metadata embedded in them, right? So these scanners try to like look through those metadatas and also get information as regards what if there are any vulnerabilities there. So at the end of the day, I just showed you guys that okay, these are possible ways that container vulnerability scanners all work itself, right? So and if we then start a journey to say, okay, we have detected these CVEs, right? We want to fix them. Fixing CVEs or trying to fix one bug to the other may lead to breaking your application itself. So you're trying to solve a problem and it leads you to another problem itself because the version of that application or the dependency for that application doesn't, sorry. Hello? Okay, we're back. So you try to solve like to fix a vulnerability and you end up breaking your application. So what do you then do, right? Are you able to fix these CVEs or are you able to like find a way to allow all the CVEs that were discovered just disappear? So imagine you saw like 50 CVEs in one Docker container or one image itself, right? And they are all graded in different like critical and different ranges itself. So the question then comes like, okay, how can I remain compliant, right? Or how can I like just deploy my applications and not really worry about it? In truth is, at the end of the short demo that we're going into, you would realize that at different points in our lives as developers, we have been maliciously compliant, right? But here we go. So at the end of the day, now we know what container scanners are looking for. Now we know what they are. We'll go ahead to start like a short demo. So I'm gonna do this. Okay. At the end of this lecture, I provided references and links that you can go and actually gain more knowledge about malicious compliance and vulnerability scanners and so many things as well. So this is like an open source project that was presented in CNCF just a couple of months back. And for these applications, I'm going to be running through a simulation. So let's get started. There are basically 5 Docker images I will be showing you guys, right? And as we go on, I'm going to show you guys like one that by default has so many vulnerabilities, right? Yeah. Okay. So it has so many vulnerabilities. Well, I know, right? Because at the end of the day, it's a Docker file and you put it there. So let's say this is the base image and you use like an old base image itself. All those files you see and all those packages and binaries itself, like they are like some of the they have vulnerabilities in them. This kubectl that you're seeing here is it's more like a very old kubectl binary itself, so it also has vulnerability itself. The trick here that I want to establish is we want to view this image and then have those 4 scanners I talked about scan these images and let us see what vulnerabilities are present in those images, right? And the goal at the end of the day is we want to get to a point where if we started with 5 CVEs, right? And we end at the 5th one, there are no CVs. There will be no CVs, right? So let's start. So everything here is mainly, like I said, I'll provide a link to the repo and you can even run it on your end and test it out for yourself, right? So at the end of the day, I built the images already, but I'll just run it and just rebuild the images itself. Make all basically is building 1, 2, 3, 4, 5, building all the images. Sorry. When you use a Mac, you always have to run this Docker daemon. Okay, but basically, right? So that's it. And I run it, and I'm going to build this image here. And when I build this image, I'm going to scan this image itself, right? So scanning here is I'll scan this image using what's it called? The 4, which is Freebie and Guide, Docker Scout, and Sneak. Okay, so I'll just wait for this to come up. And while I scan it, I would also provide like a visual representation as regards what the results were, right? So let's just watch closely so that we'll see how it goes. Okay. So now I'm gonna build all images I showed you guys. Now this is um, by building. So this very first one, let's say this is the base image. Let's call it base 0. So base 0 itself is, like I showed you guys, contains all the packages. This, let's refer to these guys like patient 0. It has all the vulnerabilities itself, right? And okay, so I'm going to scan this, and if you watch closely, it uses like different, so it uses Trivy. Oh, this is fast, but it uses Trivy, it uses Guide, it uses everything. So it scans like everything and try to get information as regards what is available. Uh, let me see. Yeah, so why that is scanning itself, right? I would go ahead and show us like what the result would be at the end of the day. So please watch closely, right? At the end of the day, right, why that is scanning for that base zero image, right? So OS packages refers to like I told you guys that when your vulnerabilities kind of look for OS packages, right? It tries to detect what the OS is. So it's detected by this color. So that is so you can see that 3V detected 64, what they call guide detected 54. At the end of the day, they all have their ways of working. So you do not expect all vulnerability scanners to bring the same result itself. So this is our base image itself. And we see that we use 4 vulnerability scanners and they all came outside with different results, right? Isn't that concerning really, right? Because you trusted this container scanners itself, right? But now let's go to the next one, which is so OS packages dependency files and binaries. So this leads us to our Docker file too. So let us imagine that I know that I know that my vulnerability scanners are looking for certain files in my Docker images, right? So if I know what they are looking for, it therefore means that, right, if I try to remove those files, would the vulnerability scanner be able to detect it? So yeah, we'll test it out. So this is the base image. So this is what I'm attempting to do. So basically, imagine that you change the contents of an HCOS, right? You change it to something that the vulnerability scanner, even though it reads it, cannot understand. So, and I go ahead and go a step further to remove that for iPine and some other things just to be safe, right? And we then run this scan again, basically like view this image and run the scan again. And this is what's going to be your result. So this was what we had, right? This is when you remove the OS, the files, or you make changes to the OS files. This is what the scanners bring now. So you can see here that Docker scan and Docker scout itself basically could not detect any OS packages. I'll go again. See, Docker scan, when we scanned the first image that had all the vulnerabilities, Docker scan was able to see 155 CVEs, right? And Docker scout was able to see 29, like from just from the OS itself, packages. And now we were able to figure out to say, okay, let us change the content of, because Composer is based on iPine. So, and I think we go to, then let's say, let us remove some of those files and let us even like make like a custom definition to say that, oh, this is not Ubuntu, this is Frank. And these guys scanned it and you can see the results. It wasn't able to detect this vulnerability. Please understand that the vulnerability is there because you can see that these other containers and canals were able to detect it, right? So, so now we have been able to reduce the vulnerability, right? Because we have been able to, if you were using Docker scan, that means you're compliant now in a way because you have been able to fix those vulnerability in a way, but it's still there. Now I'll go to the third one itself, which is packages. So now we successfully was able to remove those OS files, those OS specific files that these OSs have, right? But now we can see that for what we call for Trivi and for Guide, they were still able to detect that those vulnerabilities were there. So we want to go a step further. So say, okay, maybe Trivi and Gap were more smarter than Docker Scout here. So we said, okay, let us remove those packages, those OS packages, right? Because when, like I said, when if you scan any image, look at it very well, it detects the OS that you're using. That's the very first thing. So now we're gonna view this image, and let's say that This is our second image itself. So let's remove the packages, the OS packages from here and scan it. This is our result. I'll go back to the very first one when we started. This is our base image, base 0, that has all the vulnerabilities. When we removed the OS detection files and made some customization to it, Docker Scan and Docker Scout, Docker Scan basically could not see any OS packages itself, same as Docker Scout itself. Like I said, under the hood, Docker Scout Scan uses Sneak. Oh, anyway, let's go. Now, now that we have removed the OS packages, right? Look at it very well. Even Trivi that was smart at the first time. Now Trivi can see any OS packages. Can you see it? Same as Guide itself. So in a way, if we had scanned and we saw that there are five vulnerabilities at the OS level itself, we have successfully been able to allow those CVs disappear. But they are still there. But our container scanners do not detect them again. So this covers the very first one, which is OS detection and what's it called, OS packages. Now, our containers are no longer, scanners are no longer smart to detect that, okay, our images are based on this. So they do not have visibility into how they can identify or scan those packages if there are vulnerabilities there. So let's go to the third one, which is dependency files. What happens if, um, because if our scanners scan dependency files and they're able to understand like these are like some vulnerabilities we have based on dependencies. What's going to happen if we intentionally uh, remove it so that they do not see it? But if we remove it to break our application, right? Because it needs it. So what happens if we create like a symlink, right? If we create like a symlink itself and the scanner scan it, would that mean that let's see what's gonna happen basically? Well, yeah. So I'm gonna show you guys the file. So like I said, all this code is basically open source, really. And at the end of the lecture, I would share it and you can go there and run tests and test it out for yourself. So now we started. This was our base image itself. So let's say like you're like your package.json or your cargo.log itself. I'm trying to test something out to ensure that they do not see these files. My scanners do not see this file because we're trying to prove that your vulnerability scanners are not as effective as you think they are itself, which leads to malicious compliance. So I created a symlink and I renamed the file one funny name itself. I did that for requirement.txt and some other ones as well. So doing for each of them itself, and I'm going to scan this image now, and you're going to see what the results are. So this is where we are now, right? I'm going to like, for context, this is where we started, where we were able to detect all the vulnerabilities, right, based on what the scanners can see. This is when we remove the OS packages. This is when we remove, like, sorry, packages the second time. And this is when we created a symlink for the dependencies. Can you see something? You can see that none of the scanners was able to detect any vulnerability for the dependencies. So it therefore means that someone that wants to bypass this can basically find a way to bypass the scanners itself, right? Okay. But at the end of the day, the trick is we want to get to, okay, the trick is we want to get to a point where we don't want to see any vulnerabilities. Like we want everything here, all the scanners to not see anything. So this, I'm gonna be a bit fast now. So this brings to binaries itself, right? And I said I have like a kubectl which is really old, and I know that it has like some vulnerabilities inside it. But recall that when it comes to binaries itself, right? The metadata are embedded in it. For instance, chips itself is Go, right? The Go itself is embedded in it. So you need a way that you can package it yourself in a way that the scanners would not be able to see those metadata. And and there's something called UPX itself, right? It's a way that you can package your binaries by yourself, right? So when I run this image itself, this is what would be the result. When I package it using UPS, this is going to be the result. This is where we started. This is where we are. So I have removed this, and I just package this binary by myself using UPS, right? So the trick is the scanners are no longer able to, gap is gone, right? And Docker Scout is still able to see something, like there are still like some vulnerabilities there. They are still able to see something to say, oh, something is still there, right? But we don't want any CVs to be there. So we need to find a way to like um, let the scanners not detect anything. So given that Docker works in layers itself, right? What happens if we then do like a multi-stage build itself, right? So if we do like a multi-stage build itself, right? A multi-stage build itself, and we package all the binaries in the first image itself. And this one, we basically just copy whatever are the results and we put it here. When you scan this, what do you think will be the result? The trick there is, since Docker works in layers itself, you won't get any CVEs here. So this brings me to my point. Let us go back so that you understand what I'm trying to say. Understanding how your vulnerability and scanners work is very, very key. It doesn't mean that you're secure because you have those systems set up already. What that means is, right, you just have a good level of visibility, but it can be bypassed, right, when you know what they're looking for and when you know how to bypass it. We have been able to prove that based on these different scanners itself, we've been able to remove all the CVEs we detected, right? And we came to a conclusion that, oh, there are no CVEs, and let the application be deployed. So is it not really funny? Because at the end of the day, like the CVEs are still there, but they are not there. The scanners can see them. So at the end of the day, this brings us to understand like what is malicious compliance itself, right? You have to find a balance between when you're trying to be compliant and when you're trying to be secured itself, right? Because in your bid to just try to deploy applications to like find a way to bypass it, people can do something. I could inject something in that code itself. Your scanners will not see what I injected in that code because they are looking for vulnerabilities itself, right? So malicious compliance is kind of like it's kind of awareness to know that your scanners um, are not as efficient as you think they are itself, right? They are working based on certain files or systems that have been programmed in it, right? And this brings us to SBOM. I, because of time, I'm not going to talk much on SBOM, but like I said when I started, SBOM is a way that um, aside looking for at just your Docker files itself, right? So think about SBOM as a structured data set that has all the how do I call it, all the libraries, license, everything about that application itself, right? In a data structure format in a way. So instead of you scanning your images, you scan the SBOM itself. But I think I added it, but let's just go further. So this would bring me to what's it called? Now you know what malicious compliance is. So, and to quickly bring this to an end, I'll talk briefly on chip clarity. So, chip clarity is a vulnerability scanner itself, right? Really, at its core. And what it does differently is people have been trying to like build standard as regards SBOM, trying to make ways that you can better improve how you scan your images and scan whatever you have itself. So there are different like standards and every other thing, but think about Cube Clarity like a platform that provides a UI, right? If you work with vulnerability scanners, you know that you already have like a dashboard. Most times it's CLI. But these guys, they provide like a UI for you, and the UI that they provide is something like this. and you are able to scan like your Kubernetes cluster, your images or something. You're able to see what the new vulnerabilities are. You're able to see what the packages are, what the cans are, and just basically like so much information that you can get itself under the hood itself, because you can rely on one vulnerability scanner, right? We saw that from the results, we saw that they all presented different results. So that means that, so these guys basically use Trivia and Guide. If you know Trivia, Trivia has a very extensive database, okay? A very extensive database of like vulnerabilities and stuff. So it's very, very popular. Guide is quite, I would say, Guide from my own experience is quite popular for Python related because it's so in depth. But basically, this is a combination of both of those scanners itself. But what makes it interesting is these guys, they do not just look at your files or your Docker files or something. They're able to create S bombs. They use S bombs, right? So basically, Trivia and Skype and what's it called? No, Trivia and I think Sneak or something. They're able to create S bomb, and they're able to scan those S bomb in your environment. And because S bomb formats can be quite different itself, so QClarity found a way that they can create like a native way that they can read that information. So in summary, what QClarity does for you, or what we're trying to say about QClarity is just this. QClarity is, I would say like it goes a bit further than Trivi, right? It gives you like, instead of you using just one vulnerability scanner, you have like at least two. So that means if this one does not see this other one can see it at the end of the day. Then at the end of the day, it gives you the dashboard, the UI, and some other features itself, and it uses SBOM itself. SBOM is the way to go, but at the end of the day, not in this demo, but even SBOM itself is not as efficient as it is. There's a way that it can still be bypassed. So at the end of the day, some of the recommendations here really, we need to build like a vulnerability management system really of how we want to manage vulnerabilities, right? Do we just want to be compliant, right? Find a way to like sweep things under the rug, or do we want to find a way to fix them? And what can be fixed? What can be remediated? We finding a balance as regards it's where everything is. And we need to work towards trying to like practice using SBOM for scanning, like creating SBOM packages and using those SBOM packages for your what's it called, for your images or containers. Then QClarity, yeah, I think I like it because I use it, right? Or basically, it's open source as well, so you basically have like a CLI and you can try it out yourself. So these are some of the references I used, and it's provided, like I said, most of it is open source and all the information is there. So in summary, the thing is, when we are trying to manage CVEs and we're trying to like fix problem itself, like I said, we always have to find a balance between compliance and security. And we also want to ensure that we are not being malicious compliant when we are trying to fix CVEs, right? And lastly, using SBOM for scanning containers. Thank you. Yeah, so quickly, if you have any questions. Okay. All right. Yeah, please. Go ahead. Yeah, go ahead. Okay.
Good afternoon. Okay, thank you for the session. Very good one. But different points in our I think one way or the other we might thank you running a package, use for struggling, especially using version of different now for what you for the presentation. The first question I want to ask is in the process of you making those editing, changing their names and all, after when you now package to work,
Okay.
you try to rename all the OS and all of that. You deploy that package, will it still work that way after it has And the second thing is, if it works,
And
so
the second thing
vulnerability
is,
most
if
times is
it
okay.
works,
You want to
the
also, you
essence
don't
of
want to be
vulnerability
exposed
most
to
times
hackers
is
and all.
you want to also, you
These
don't want
hackers
to
could
be
also
exposed
use
to
this some
hackers.
software, which I
And
believe
these
they
hackers will
work
also
the
use
same
this
way
some
of the
software, which I believe
scanner
they
work. So
work the
if
same
you
way
are
of
able to bypass the scanner,
scanners work.
is
So
there
if
a
you are able to
possibility
bypass the
that
scanner,
when
is there
hackers
a
want to,
possibility that when
attack
hackers
you,
want
they
to
wouldn't be able to,
know
detect
attack
that thing
you,
that
they
will give
wouldn't
them
be
their
able to detect that thing that will give them their.
Okay, thank you. So quickly, let me say, I'll start from the second one. You know that security is at different level, right? And if an hacker wants to hack you, no matter what you do, you can only build systems to protect yourself. You will be hacked. It's my own philosophy, I know, right? Well, you can build good, reliable systems to support it, but you have to be aware if if we didn't have this conversation as regards finding a way to bypass those OS detection, would you know that there's a way to bypass it? You can mitigate what you do not know. So that means if those hackers are well aware of those workarounds, it means that you are in a way you may be vulnerable as well. So it is why we try to be aware about all these things. Then to answer your first one itself, when you change, okay, time is fast spent. So, but basically, when you change your OS packages, right, it's more like I don't know if it doesn't change the functionality, it doesn't spoil your application. Your application does not. You understand? It's still there. It just as regards that your application is able to work as it should, right? But you are just making some modifications to which, like how like the containers look for those files that are no longer there. You creating a sim link does not remove the file from there. It just means that the scanners are looking for that file, right? But the file is no longer there, right? You created a way that it bypasses it. So it doesn't really break, it doesn't, uh, what's it called? For the application. Okay, yeah. Software bill of materials. Yeah, software bill of materials. So SBOM is I think it's part of my yeah. This is it. Yeah.
All right.
Okay.
So yeah, my question is, can we relax the rules of open clarity using the CLI so that we can better integrate it into our pipelines and based on
Yes, you can configure it. Yeah.
awesome. All right, last one.
So I've used Sync and Data Scout, and usually what I do is I ask the client, what do you use to scan when you don't tell me the vulnerability? If you tell me Sync, let's use Sync. And would you say that bypassing those vulnerabilities is better than changing the image? So what I just do is, if you go to Docker Hub, you can just see images and vulnerabilities and the levels, how high, critical, or whatever. Would you say we should change the image or bypass the vulnerability?
No, so please let's be clear. The fact that you choose to be maliciously compliant does not mean that you not be hacked. Those CVs are well present there. The only thing is you do not have visibility to them. And as point of note, Docker Scout uses Cynic under the hood, so you're basically using the same database. Okay. Providing the links. Yeah. Okay. Yeah. Sure. All right. Thank you. All right. Thank you so much, guys.